In this example, we are asked to draw an accurate graph of the function 3x plus 2y equals 16. Now, because this is written in general form or standard form, we cannot just look at this equation and identify the slope or the vertical intercept. We are going to need to do some work in order to get those things. The first thing we're asked to do is rewrite it in slope-intercept form. So what we're going to need to do is solve for y and rewrite this linear equation in slope-intercept form. So I'm going to copy it down here. 3x plus 2y equals 16. Solve for y. So I'm going to subtract off the 3x minus 3x minus 3x. On the left, 3x minus 3x gives you 0. So you're left with just 2y equals 16 minus 3x. Now we have to divide everything by 2. We're solving for y here. So now we've isolated y. On the right-hand side, I'm going to go ahead and break this up into two separate terms. We have 16 over 2 minus 3x over 2. Simplifying, 16 divided by 2 is 8. Minus, and I'm just going to rewrite this 3x over 2 as 3 halves x. Here is this linear equation written in slope-intercept form. Now the nice thing about this, now we can just look at this equation and know what the slope is and what the vertical intercept is. So the slope here is the coefficient of x. It is negative 3 halves. So it's negative. We know our line should be decreasing. The vertical intercept, the constant term is 8, so our vertical intercept is the ordered pair 0, 8. And right there is enough information to graph the line. We're also asked for the horizontal intercept, however, so I'm going to go ahead and find that. Now remember, to find the horizontal intercept, the idea is you set the output, or in this case y, equal to 0, and solve for x. So using the slope-intercept form, this would mean having 0 equals 8 minus 3 halves x, and solving for x, which we absolutely could do, but we could also use the given equation. This 3x plus 2y equals 16, we could use it to find the horizontal intercept. So I'm just going to write this out to the side here, or we could use 3x plus 2. Now remember, we're setting y to 0, so 2 times 0 equals 16. Notice this equation is going to wind up being a whole lot easier to solve. So we have, following this through, the 3x plus 2 times 0 is 0, so that's just equal to 16. Divide by 3, divide by 3. The 3's give you 1. 3 divided by 3 gives you 1, then x, or just x, equals 16 thirds. This is the same answer you would have gotten if you had solved this equation over here. So our horizontal intercept is the ordered pair 16 thirds 0, or rewriting this improper fraction as a mixed number, 5 1/3 0. Now to our graph. Because the horizontal intercept is a fraction, I don't want to use it as one of my plotted points. I'm going to use the vertical intercept, 0, 8. That would be right here. There's 0, 8. And the slope is negative 3 halves. So the slope is negative 3 over 2. You could also think of it as 3 over a negative 2. All right, knowing what to do with that negative sign is very important. So here you would go down 3 units, right 2 units. Here you would go up 3 units and left 2 units. From this starting point that we've already defined here, this vertical intercept. So from this point, going down 3 units, right 2 units, lands us right here. The coordinates are 2, 5. Again, down 3, right 2. Now we are at, let's see, 4, 2. Again, down 3, right 2. Now we are at 6, negative 1. Down 3, right 2. Now we are at 8, negative 4. Down 3, right 2. Now we are at 10, that looks like negative 7. And now we just need to connect the dots to draw our line as neatly as possible, connecting the points with as straight a line as we can. There we go. Notice the line is decreasing, as it should have been. Also notice the horizontal intercept falls right in between 5 and 6, which is where it should be. So this is the correct line.